Let's start with the third video lecture for geometric progression. Now, this lecture is about the sum formula. The sum formula to find the sum of all the terms in a particular series. This sum formula always starts from the first term and it will add up all the terms till the number of terms that's given. For example, if a series has 5 terms, the first term is given, the common ratio is given, then we will get the sum of all these 5 terms. For example, look at the series 2, 4, 8, 16, 32. I can simply add these up individually. It's a GP. First of all, the first term is 2, common ratio is 2. And if I add up all the 5 terms, I get a total of 62. What if there is a formula for this? There should be a formula for this, because what if the number of terms are much more? What if the number of terms are 100? Therefore, the mathematicians, they came up with the formula S in sum of n terms. Sum of n terms becomes a bracket r to the power n minus 1 over r minus 1. Now, the n is circled in blue for the reason that now the numerator is simply n. It's not n minus 1, unlike the term formula. In the term formula, the formula was a r raised to power of n minus 1. In the sum formula, it's a r raised to power of n and then minus 1 on the side. Look at another series. This time, the first term is 1, common ratio is half, and there are 4 terms that I've written. 1 plus half, plus 1/4, plus 1 over 8. In fractions, it comes out to be 1/7 over 8. But what if I use the formula? When I use the formula, of course, the sum of all these 4 terms is positive. But in the initial steps, the numerator comes out to be negative, the denominator comes out to be negative, and then the 2 negatives cancels out, still giving you a positive value, which is 1/7 over 8. That means when the common ratio is a fraction, a small fraction, a fraction which lies between minus 1 and 1, this situation will arise. What if we were to modify this formula? For values of n between minus 1 and 1, the formula can be changed and it can be written as 1 minus r raised to power of n over 1 minus r. It's the same formula. All we have done is that we took a negative sign common from the numerator, a negative sign taken common from the denominator, and the 2 negatives cancels out. So now this is a convenient formula for the reason that when we are going to do questions a little bit more advanced, in which the value of r is unknown, then we have to decide on the right formula, which formula to be used. Based upon the hints given in that question, if the numbers are increasing in size, then we would be using the formula Rn minus 1. If the numbers are decreasing in size, we would be using this formula, which is written over here, 1 minus r raised to power of n. Now, look at these questions. Find the sum as far as the term indicated in the square brackets in each of the following GPs. For example, look at part B. Do you think the terms are increasing in size? The first term is 3, common ratio is negative 2, and they're asking for sum of all the terms up till the 10th term. Technically, they're asking for sum of 10 terms. So the first formula is better for this one. Of course, you would be getting the same answer from the second formula also, but the first formula is made right for this. If I look at part G, in this one, the first term is 1, common ratio is 1/3. Then which formula is more suitable? It's the second formula. Sn is 1a 1 minus r raised to power of n over 1 minus r. Now, this is a number line, and on the number line, I have labeled ratio, the common ratio between minus 1 and 1. When the common ratio is between minus 1 and 1, this formula is useful. This is just a summation of what I've explained earlier. And if the common ratio is r greater than 1 or r lesser than minus 1, if it's an integer, if it's a fraction like 1.5, okay? So anything that lies in that purple range, we would be using the other formula. Now let's look at this question. The common ratio of a GP is -5 and the sum of the first 7 terms of the progression is 449. First of all, it's a GP. Common ratio is given. First term is missing, but they have given us enough information to find the first term. They have given us the info that the sum of the first 7 terms is 449. So now I would use the sum formula. S7 is 449, and then S7 is A1 minus Rn raised to power of n, R raised to power of n minus 1 over R minus 1. So 449 is A minus 5 raised to power of n minus 1 over minus 5 minus 1. Now keep in mind that expect the unexpected. Do not expect all answers to be exact integers or all answers to be exact fractions such as 1.5, 2.7, something like this. You end up with an answer such as this. A is 1 over 29. The main thing is you have to trust yourself. You have to believe in yourself. You have to believe in the working that you are doing, that whatever you are doing, if you are doing according to the rules, you would be getting a correct answer. Let's move to the next question. The next question is about a GP has a first term of 1 over 11, a common ratio of 2, sum of n terms is 93. Now A is given, R is given, sum of n terms is given. What is missing? They are asking us to calculate the value of n. So again, plugging in the values in the formula, but since the common ratio is 2 over here, so this time I am deliberately using the wrong formula. Wrong formula in the sense that what is not made for this particular thing. It should be 2 raised to power of n minus 1 over R minus 1. But even if you use the wrong formula, since the value of n is unknown, you can still find the right answer for this one. So according to indices, you find the value of n, that comes out to be 10. Something like question number 18. Given that the first term of a GP is 5 and the sum of the first 3 terms is 105, find the possible values of the common ratio. And in each case, write down the corresponding values of the first 3 terms of the series. A is 5, sum of 3 terms is 105. What is missing? The common ratio. Now, in this particular question, even if I apply the right formula, there is an issue. The issue is the level of 9709 math, P1, cubic equation is not part of the syllabus. It's not that we cannot learn cubic equation. Yes, we can. But technically, it's not part of the syllabus. That means the examiner knows that there has to be an alternative way of finding the sum of first 3 terms. So instead of the formula, if I add up the terms individually, what will happen? The first term is A, the second term is AR, the third term is AR square. If I add these 3 terms individually and equate it to 105, I take A common out. I already know the value of A, which is 5. So therefore, if I simplify my equation, it becomes a quadratic equation. Take all the terms on the left hand side and it should factorize because the value of R will be exact, whether it's an integer or a fraction. So middle term factorization is used over here. Knowledge of O-level basic maths is applied over here. You get 2 values of R and both values are acceptable because the examiner already suggested that you have to find the possible values of R. So R comes out to be -5, R comes out to be 4. Now keep in mind that there is one value of A but 2 values of R. That means you have 2 possible series. The 2 possible series are A is 5, R is -5. So you get these 3 terms. How do you get these 3 terms? A is 5, you write 5 as it is. You multiply by R to get the second term, which is -25. You multiply -25 with -5, you get plus 125. This is one possible series. The other possible series is the first term is 5, common ratio is 4. So 5, 20, and 80. 5 into 4 is 20, 20 into 4 is 80. And it so happens that if you add the 3 terms of both the series, they both add up to 105. So now in this video, what we have discussed from basics, why is there a need for a sum formula? Why there are two sum formulas? Depending upon the values of R, you have two formulas. As such, it doesn't make a difference, but it's better to use the right one in the right place. And how do you find for unknown value of A, unknown value of N, unknown value of R? So these are three nice questions that I've illustrated over here that will explain you the sum formula in full detail.